In this video tutorial, we will see about the optical path difference in thin film and how colors form in thin film. Before we approach to the actual article, basic concepts, basic phenomenon required for this article, that both the phenomenon we will see first. First phenomenon, that is the reflection of light. When incident light on the mirror makes certain angle with the normal, which is angle of incidence I, and further that light ray bounce from the mirror making certain angle, we call it angle of reflection, and that ray we are calling it a reflected ray. Both angle of incidence and angle of reflection lie in the same plane. Both are equal to each other. So this is about the reflection of light. Next phenomenon of light we will see about the refraction of light. When light ray incident on the glass slab, one of the surfaces of the glass slab, in this diagram we are observing that light ray incident on the upper surface of the glass slab, and that light ray traversing from rarer medium into the denser medium. It makes certain angle of incident at normal, which we call it angle of incidence. Actually, if there is no denser medium, then that light ray follows the path as shown in the diagram with a red color. But due to the concept of refraction, light ray is shifting from its original path and it is bending when it travels from rarer medium into the denser medium. So bending of light ray from its original path into the denser medium, when it travels from rarer medium into the denser medium, this phenomenon is called refraction of light. Further, when that light ray goes from the glass slab into the again rarer medium, then it follows the parallel path of the light ray if there would not have been a denser medium. So this is about the concept of refraction of light. Both the concepts we require for this article, and that is why we are considering here these concepts. Now we will see left ray diagram. In a left ray diagram, suppose AB and CD are two parallel surfaces of transparent thin films formed by refractive index mu, and thickness of thin film is denoted with letter small t. Light ray PQ incident on surface AB makes an angle of incidence I with normal denoted with a letter capital N at point Q. That ray further partially reflected and partially refracted. Both the concepts we have seen, reflection and refraction earlier, which were necessary for this article here now, and that is why we have seen these both the concepts here earlier. See, in a ray diagram, QG and QR are reflected and refracted rays respectively. Angle of refraction is denoted with letter small r. Ray QR incident on surface CD. Look at the diagram. Ray QR incident on surface CD partially reflected with ray RX, as you can see in the diagram, and further partially transmitted as a ray RS. ray Rx partially refracted as a XY in air, rays QG and XY are both parallel to each other. As you can see in delta, that is the path difference, is equal to into bracket path into bracket QR plus Rx bracket complete minus path OQ. This is equation 1. Path difference delta is equal to mu into bracket QR plus Rx minus OQ. This is equation 2. According to Stokes' theorem, when light of wavelength lambda is reflected from surface of optically denser medium, it suffers phase difference of pi radians or path difference of lambda by 2. Hence, path difference between two reflected rays is given as delta is equal to mu into bracket QR plus Rx minus OQ plus minus lambda by 2. So this is equation 3. To find QR and Rx, consider triangle QMR. From triangle QMR, cos R is equal to MR divided by QR. This is equation 4. Therefore, QR is equal to T divided by cos R. This is equation 5. From ray diagram, QR is equal to Rx. Rx is equal to QR is equal to T divided by cos R. This is equation 6. Now find OQ. According to Snell's law of refraction, mu is equal to sin I divided by sin R. Therefore, sin I is equal to mu sin R, and this is equation 7. In triangle OQX, sin I is equal to OQ divided by QX, that is OQ is equal to QX sin I. QX is equal to twice QM from diagram is equal to twice mu QM sin R. This is equation 8. Angle QRM is equal to R and tan R is equal to QM divided by RM. Tan R is equal to QM divided by T. From this, QM is equal to R tan R. This is equation 9. Substitute equation 9 in equation 8, we get OQ is equal to twice mu to tan R into sin R. This is equation OQ is equal to twice mu T tan R into sin R. That is OQ is equal to twice mu T into sin square R divided by cos R. This is equation 11. Hence substituting equation 6 and equation 11 in equation 3, we get as path difference delta is equal to mu into bracket twice T divided by cos R bracket complete minus twice mu T into sin square R divided by cos R plus minus lambda by 2. Therefore, path difference delta is equal to twice mu T divided by cos R into bracket 1 minus sin square R bracket complete plus minus lambda by 2. We know 1 minus sin square R is equal to cos square R. From that, delta is equal to twice mu T divided by cos R into bracket cos square R plus minus lambda by 2. From this, part difference delta is equal to twice mu T cos R plus minus lambda by. There are two cases. Case 1, constructive interference. As you are looking about the constructive interference, and second case, that is the destructive interference. If the path difference is integral multiple of lambda, then film appears bright in the reflected light, that is delta is equal to m lambda. So you are watching that equations. And if the path difference is odd integral multiple of lambda by 2, then film appears dark in the reflected light, that is delta is equal to m lambda. So this is about the cases of constructive interference and destructive interference, how they appear. So this is about the optical path difference and color formation in thin films with interference.